Hi, yes, today I'll be talking about demonstrating the hydro-ecological response to return low flows in the MLR. Now this project is very much linked to what Paul Wainwright was talking about earlier, and this is really about trying to understand the on-the-ground impacts of putting those low flow bypasses in and the improvements that we then see in the catchment, or hopefully see in the catchment. Sorry. Oh, where am I going? Down, up.
Yes, down one.
Cool. So this is basically the planning context. I haven't got long, so I'm just going to briefly talk about it. Paul also mentioned these key projects that we talked about. If you look down the bottom, we have securing low flows and flows to the future, for the future. And these are key programs which are implementing low flows, which are part of the implementation of the water allocation plan. Flows for the future also, because of the nature of the eastern Mount Lofty ranges where that work is done, also feeds into outcomes for the basin plan. Now, in terms of the project, this actually sits under a risk management framework. So in terms of water allocation plans are based on a risk-based process. And you actually would have seen the outworking of that in the Barossa work that was recently presented. So that project actually sat in the risk identification, risk analysis and evaluation stage of this process. Whereas this one, we've gone through that process through the water allocation plan, and now we're up to the risk treatments. We've identified that there is a risk of not returning low flows, and now we're actually providing risk treatments through low flow bypasses. And then the process of this talk is to talk about then the monitoring and evaluation of putting those low flow bypasses in. And so this is just a little bit of the background of the ecology of it. You can see that the catchment A is dry, is broken into a series of pools, and that interruption of a natural flow regime impacts on the ecological integrity of that system. It impacts your water quality, your macroinvertebrates, your fish, the things that live there, and then overall the other benefits that those systems provide. So providing low flows is really important to sustaining all the processes within these systems. So the risk treatment, as I said, implementation of low flows. And so the key question of the monitoring program for this is then, to what extent has the implementation of low flows resulted in the maintenance or improvement in condition of water-dependent ecosystems in the eastern or western Mount Lofty ranges? So this is a hydrograph, and this is sort of our expected hydrological response. We can see that we're expecting that we will extend the flow season, thereby reducing the intermittency, so reducing the amount of time streams are dry. This is important, and also then changing the timing of when those first onset of flows happen. And those first onset flows are really important things for cueing fish breeding and those type of processes, as well as maintaining the invertebrates that are the food source for those higher order creatures. So when we developed this monitoring program, we needed to look carefully at the spatial scales that we were going to look at, and then also be able to detect a response. Paul talked about the trial sites, and that really fits in the dam or fine scale monitoring part of the work that we're doing. Whereas we looked overall, we thought that the best way of determining a response was to look at a catchment and to try and develop a before-after control impact design, where we can get into the catchments and look at things on the ground before we implement these devices. And as Paul mentioned, this was also a really strong desire of the community as well. Rather than just relying on model data, they wanted to see what was happening on the ground. And so, as I said, we developed an MBACI design, a before-after control impact design, and we're kind of in the middle phase where we are at the moment. And we've got two catchments that we're working in, one in the eastern Mount Lofty ranges and one in the west. And we're using the data from both to determine what the response at a catchment scale we have to these to the low flow bypasses going in. And we're looking at key indicators. Whoops. We're looking at key indicators of water quality, macroinvertebrates, in-stream vegetation and fish. And I can't tell you more about that, but we've also done an assessment about the timescales over which these things respond, and then their likely timeframes of response as well. And we've also chosen indicators that also have a social connection. Somewhat unfortunately, concurrently, a citizen science program that is linked to this work is being spoken about at the same time in another room. And so that also links in so that we're able to get community buy into this kind of work as well. So basically we've come up with a whole series of key evaluation questions for the different components that I've talked about. The hydrological ones being about the wetted width and then the hydrological connectivity. And then we've also got ecological indicators of macroinvertebrates, vegetation and fish. And some of the methods that we've used, so we've got fixed transects for vegetation that go across the stream sites where we're recording all of the aquatic and terrestrial species along those transect lines before and after we return low flows. For the macroinvertebrates, we're looking at things like invertebrate diversity, and then also a set of groupings of species that tell us about the resistance or resilience of the system as well. And that work was done in a previous Goiter project where we came up with those groups. And so we're looking, hopefully, we're looking at this MBACI response to be able to analyse these impacts. And so I hope that I have my map in here, but it looks like that's not in here. I was going to show you two catchments that show where we've got control and impact areas across both of the different catchments, and then we'll be able to detect the difference before and after we put these flow bypasses in. And so the expected outcomes for the project are that we've got evidence that the program is meeting its goals, is or isn't meeting its goals, data and evaluations that will provide some of the requirements for the basin plan, data to further refine the low flows program through adaptive management, a better understanding of how the systems respond to changes in the flow regime, an opportunity for community engagement in the health and restoration of local waterways, as I've said, with that complementary project that's happening. Data to assist ultimately with the review of the water allocation plan, and evidence that returning low flows is possible and effective at multiple spatial scales. Thank you very much.